that says convert from radians to degrees. So I guess this type of angle we should be familiar with. Good morning. So in exercise 47 that I believe we had for the quiz last Tuesday, you need to take pi over 3, and to convert it, we multiply it by 180 over pi. So this way the pi is going to cancel, and we end up dividing 180 by 3, and that gives us 60 degrees. I like to also show you one very interesting place where you can see all these conversions. It's at the very end of this textbook. Actually, it's the last page, but need to scroll up a little bit, where you can see this circle. Good morning. So you see the circle with various angles in here. And we can also notice that we have angle such as a pi over 3 in it. And according to definition, we actually have this arc length from 0.10 for the circle of radius 1. That's why it's 1 for x and 0 for y. And also we can see the correspondence of 60 degrees angle with that radian measure of pi over 3. And that's something that we're going to heavily utilize in this section, as well as in the next section, as well as throughout the whole class. So we can keep this page opened. And what I want to do is get another copy of this textbook for convenience in here. So I'm going to type Sylvan and then pre-calculus and then PDF, and it's going to actually appear. And we take a choice number 1, right? So I'm just opening another copy of the same textbook and showing those people that didn't have a chance to click on this download key for some reason. Could be legitimate, of course. And this way you'll be able to save a copy. But my goal is to actually keep using these formulas from the very end of the textbook. And that's why I think it'd be convenient if instead of just going back and forth from middle of the textbook to the very end of it, just to get the formulas opened, and that way I don't have to jump back and forth with these pages, which is a little bit annoying, I think. So anyways, let us take a look at the next section that just talks more about exact same story. I just want to make it a little bit bigger so you better see this. So we now have very interesting definition that deals with function sine as well as its friend cosine. So what I can do is produce the new favorite picture of this so-called unit circle. So I hope this is something that will mean a circle. And then we're going to consider point on this circle. And I want to make sure it's a unit circle. So its radius is equal to 1. So it intersects at points 1, my x and y axis, as well as at points -1 on the left and down below. So when I connect that point on the circle with the center, with the origin, then I'm going to get a angle. And looks like here they want to call the measure of this angle as letter T. You can call measure of angle with any letter you like. So we get pair of coordinates of this point. There's going to be x coordinate that they like to call as a cosine of that angle T, and also y coordinate, which is called as a sine of that angle T. This is a definition. So that's something that one needs to remember, right? So you need to remember definitions or to write them someplace, because the sooner you start to remember that cosine of angle is nothing else but x coordinate of that point on the unit circle, on the circle of radius 1, the sooner you remember it, the better you feel about this class. Because actually that's pretty much all one needs to remember for trigonometry, what cosine is and what its friend sine is. So those are just x and y coordinates of point on the unit circle. So I'm gonna try to get used to this definition by taking some exercises, and in this section there are some other trigonometric functions present, but I just want to look at sine and cosine at those y and x coordinates today, because I just want you to start to feel comfortable with this key ideas from the section 2 of chapter 6. So we can start with some exercise. Let's say 13 is recommended. We usually do skill building problems, and what I can do is take a look at the unit circle and then get the point on this unit circle that has coordinates radical 3/2 and 1/2. So notice that this pair is x for radical 3/2 and y is 1/2. So I can imagine the point right in between of 0 and 1, because again, that's a unit circle. So in between 0 and 1, and get the picture of it somewhere here on the unit circle. And then it turns out that the other coordinate of it must be a square root of 3 divided by 2. And one can say, why is that such a case? Well, Pythagorean theorem is what we can utilize to check this out. So please notice that since we have everything perpendicular, so this side here will be exact same as the one here, simply because this is 90 degrees angle, and translated that little red segment to the right side will actually give me that little red segment, which is nothing else but the side of my right triangle. And the other measurement here will be a square root 3/2. That's what I claim. And the hypotenuse is 1. And we're going to utilize the fact that this is a right triangle, because again, this is perpendicular to the x-axis when we draw from the point down to get its coordinate. And then we can also call sides of our right triangle with letters A and B, and its hypotenuse equal to C. So remember the statement of Pythagorean theorem. A squared plus B squared is equal to what? C squared, right? If you don't remember it, then, well, look at it. That's something that we are going to utilize here. So I can just replace my A and B as well as letter C with those numbers. So we're gonna also have to square this and then add it with a square of 1/2 and see if indeed this is equal to 1 squared. Well, if I have a square root, when I square it, I get just no square root, just 3, and then I square denominator, I get a 4. And with 1/2, when I square it, I get a quarter, because 1 squared is 1, and again, 4 is on the bottom. So when I add these 3 and 1 fourths, the sum will be 4/4, which is indeed equal to number 1. So these pairs in this entire group of exercises looks like they deal with radical 3/2 and something else. And they are all about right triangle with hypotenuse 1. So you can check and see that squares of all of these so-called sides or x and y coordinates will give you number 1. So what I'd like to do is decide the angle that we produce in here. And if I imagine myself another triangle reflected downwards, I'm talking about reflection through the x-axis of it, then notice the sides here and here must be the same because they're radii, and this little side is 1/2, the red one, and so will be the other lower side, 1/2. So notice that this triangle has 3 the same sides, and they're all equal to number 1. And since sides are the same, then the angles of this triangle also have to be the same, and same angles means they're all equal to 60 degrees, because 3 times 60 is 180. So we have so-called equilateral triangle with equal angles. And this enables me to say that the angle we have here, and it doesn't matter why you came late. I'm so happy that you actually made it to class. So no explanations needed. In fact, if someone can't even come late, somebody sent me email say, Alex, I was actually in a class, but I got to sleep. It's just so boring with your voice and stuff. So I got to sleep. And that's fine. At least something I could do for you to help you relax. And since I record my lectures, I just need to watch the recording. So it doesn't matter as long as you're having this recording, and you can send me the answer for the quiz. I'm just kidding about boring, so I hope not. But again, various things happen. People get tired. Like I, for example, woke up at 2 o'clock in the morning for some reason, just had some kind of nightmare. So I guess couldn't get a sleep until now. So various things happen. That's why point of story is that you have a recording of lecture. If you miss something, you actually did not, just check your email later today, and you will find whatever you missed anyways. So that's why I tell people, if you can't make it to class, then it's fine. Don't worry. Just make sure you check the recordings that I always email later. So anyways, the point of story was that we actually came up with a triangle with angles 30 degrees and 60 degrees here. And that's the idea for cases whenever triangles have sides 1/2 and its friend radical 3/2. About the quiz, actually, the long weekend is coming. Did you know that? The Labor Day weekend on Monday. And I think it's not very fair to our class students because you don't get to experience it, right? Because you have a class today and then next class is on Tuesday. So you're kind of skipping that weekend. So I think in the spirit of common holiday, I'm not going to give you a quiz. That's, I guess, what I can do for you, right? And yes, the class starts at 9:50 every Tuesday and Thursday. And next week will be the same thing, 9:50 in the morning. That's in the schedule of classes. So today I'm not going to give you a quiz in the spirit of common holiday. Yes, we had already a few quizzes. That's good. And we'll have one maybe next week on Tuesday. So today's goal is to get used to the idea of so-called formula sheet at the end. So this sheet of formulas is here. I already shown today this location at very, very last page of this textbook. So you can see actually the case that we just worked out, and we were able to show that we have here the triangle, and sides of this triangle will be one of them is square root 3/2, and the other is 1/2. So y coordinate is here 1/2, and its friend square root 3/2. And that's for angle 30 degrees, which is here. And this angle could be also treated as if it was pi/6. So that's where this little diagram, this circle diagram actually comes from. So now I can use it whenever I have some other points in the circle, because you can probably also notice that there is a pair analogous to what we just worked with, but on the other side, it's symmetric here. So if you considered another triangle reflected through the y-axis, then here also we should have same angle of 30 degrees, right? And this will be the right triangle, so that one will be also 60. And the only difference is that x coordinate is negative because x is going to the left, because y is still same, y is still 1/2. So that's why on this picture, I actually don't have to have that many angles, because I could just use ideas of reflections and produce all of the answers. But I think it's helpful to see this picture and to be able to locate it anytime you need. So let me try one more exercise here with this radicals 3/2 story. Turns out it's one of the very popular values. So it's an exercise number 14, actually. And in this exercise 14, it looks like I do have pair with x is equal to 1/2. So I guess I need to maybe clean this a little bit so we can nicely utilize the same exact circle. You probably notice I have a little problem drawing those circles. That's why I'm trying to, I guess I'll be practicing over weekend, but right now I'm trying not to draw another one. I'll just use the old one. So in exercise 14, we have a x coordinate 1/2. And I always start with 1/2 because, again, this is a unit circle. So it's not hard to cut this into the segment 0 to 1 into 2 equal pieces. And then we need to go down So if I draw the perpendicular to my x-axis, find the point here on the circle, then the other coordinate of this will be negative. And since we already have 1/2, its friend, square root 3/2 will be here with us, but it comes with a negative sign since we have a y-coordinate below the x-axis. And that's okay, because triangle still has same angles. One of them is 30 and the other of them is 60. So if you remember that the angle that we're actually working with here is going to be the negative 60, because if you start at the positive direction of x-axis, it's going to go with a minus sign. And one can say, Alex, who told you you have to start like that? Maybe your angle goes this way. Well, we'll always start at positive direction of x-axis. Always means always. So we have negative 60 degrees angle, even though the other is 30, but here we say negative 60. And I was able to find the angle for exercise number 14 using symmetry. And turns out this value 1/2 and its friend square root 3/2 will be with us from now on. Those are very popular angles. Looks like they're dealing with either 60 or 30 degrees, or all of their cronies, such as if you, like in the previous case, take something like 30 or 60 from some other direction, you can always convert it using this little circle formula. I say which little circle? Well, the one that I just shown you at the very end of the textbook with all of these angles. So notice that they all really deal with pretty much same numbers. It's 1/2 and square root 3/2, and one of them may be with a negative sign, but they're all here. So you have lots of them present on a circle. So they are very popular. And there is another very popular angle that deals with points such as a square root 2 divided by 2. So these are, again, 4 different possibilities. Let me show you these. And they all look like 45 degrees, right? Coordinates of 45 degrees angle. So let us first of all justify why 45 degrees corresponds to this angles of multiples of 45. In fact, here you can see it from the picture, 45 or pi divided by 4, right? If you break this pi angle into 4 equal pieces, then one of them will be pi divided by 4. Or if you take 2 of them, there will be 2 pi over 4 or pi over 2. Or if you take 3 of them, it'd be 3 of these pi's over 4. That corresponds to 135 degrees. And so forth. You can keep adding 45 degrees and get some more values. So what's going on here? Why is that square root 2/2? So for convenience, I can consider this little triangle here that will have angle 45 degrees, right? So let me maybe go to another page, to the other copy, because there is more room here, and get this 45 degrees angle in triangle, and see what be the other angle here in this case. And looks like, since we have right triangle, so we have 90 degrees here. I just put a box. I don't want to write 90 all the time. It just takes lots of room. So the other angle in this triangle also has to be 45, right? Because the sum of these two 45s should be 90, as third angle is also 90. Because no matter what triangle you consider, the sum of three angles will always be 180 degrees. So two 45s, and this tells me that these two sides must be the same. So my hypotenuse here is 1, so I already know that, so we call hypotenuse as C. And now there are two sides in this right triangle, they both the same, so I can call them both as letter A. So I can say that since A squared plus B squared, but it's same as A, is equal to C squared, and if C is equal to 1, then I can say that 2 times A squared is equal to 1, or A squared is equal to 1/2, right? So we just need to find A, and I can square root numerator, square root of 1 is 1, and square root denominator to get a radical 2. And if someone wonders why this is square root 2 over 2, well, because they want to make sure that your denominator is a whole number. And this way, in denominator, we're going to get just number 2, but radical 2 is on the top. So the point is that both of these sides are going to be the same and equal to square root 2 over 2. Just like that. So for example, if I tackle number 17 here that has square roots 2 over 2, well, then I can, again, imagine a unit circle, or actually draw that new favorite circle with radius 1, and then try to see what location for this point is going to be. So let me circle for you. Okay. And point 1 coordinate is going to be negative square root 2 over 2, and the other is positive. So negative means someplace here. So angle 45 degrees, I'm gonna put somehow like that, right? So you can treat of 45 this way. So, and again, minus radical 2 over 2 for x, as well as positive square root 2 over 2 for y, will give us the angle, which is going to be like 45 degrees taken 3 times, right? You have 145, 2 45s, 3 45s. Or you can take away from 180, 45, and you will still get the same exact value, which is 135 degrees. So it looks like it's just 45 plus either 90 or plus 180. So this is how we can get this intuitively. And looks like this corresponds to the point with coordinates that has angle of 135. In fact, if I go back and see that x is cosine, so I can write that negative square root 2 over 2, that's the x coordinate, which is a cosine of this angle, 135 degrees. And the y coordinate, which is positive root 2 over 2, is sine, right? 135. Why is that? Well, that's how we define them. So x coordinate is cosine, so this is your cosine, right? And the other coordinate, y coordinate, is sine. It's always like that. That's definition. Again, we need to remember definition, because if you don't remember how we define, let's say, a dog, then you're gonna see some bird is flying, say, oh, that's a dog. No, 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 that's not a dog, that's a bird. So you want to make sure you know those definitions. That's very important. So, as I'm not gonna give you a quiz today, so I'm gonna have you, well, at least something I can do to give you a Labor Day spirit. So I can do another exercise in here. And again, I'm just gonna hear about sines and cosines. So let me try problem number 21. Looks like that's another recommended little exercise that has a sine of 11 pi over 2. So I need to think of this angle and I will make a picture of it. 11 pi over 2. Remember that we declared that 360 degrees rotation is all the way around, which is equivalent to 2 pi on the unit circle. And if you divide both sides of this by 2, that's going to be 180 degrees. So pi is corresponding to 180 degrees. So whenever I think of pi, then it means that I have to take this 180. But since it's over 2, then I can think of it as pi over 2 or 90 degrees angle. See, my goal now is to make sure you start to get used to this intuitive conversion. Degrees, 90 degrees we used to call right angles, but now it's pi over 2, which is actually the same thing. I say, Alex, what if I call 90 degrees all the time? That's fine with me. I will understand it as long as you understand what this means, because in lots of exercises, you will be given not degrees, but this pi things, which is called radians. So there's pi over 2, this 90 degrees angle. Now I have to take 11 times, right? Because we're given that we have 11 pi over 2. So I need to go 2, 3, 4. That's full rotation. Then 4 more, that's going to be 8. That's another full rotation. And then I get 3 more, 8 plus 3. So it'll be 1, 2, 3. So I'm going to end up right here at this point, and that'd be my angle 11 pi over 2, because since they're talking about sine of it, and also its friend cosine, it means that I just need to know coordinates of this point on my unit circle, and looks like x coordinate will be 0 and y coordinate will be -1. And because of definition that we already saw today, right? So it's still here in the upper right corner. I would say this is the most important definition for this class. I can right away say that cosine is my x coordinate and sine is my y coordinate. And of what angle? Well, the angle we just produced, 11 pi over 2. I think with pi's, it's kind of more straightforward, because if you decide to turn this into degrees, what kind of angle would that be? So it's a 360 plus another 360, 720, and plus another 270, right? So it'll be like 990 degrees. When you look at that, so many degrees, you're probably not going to get so much intuition, rather than you just saw pi over 2 taken 11 times. So you can easily put this on the unit circle. Maybe not that easily, but I think it's more straightforward compared to if I put 900 something degrees for you, then you probably have a little bit harder time. And that's the advantage of using this radians, because I think this way you start to feel a little bit better about making pictures. But please notice that sine and cosine stay the same. And if you keep rotating it more and more and more times and end up at the same point, but it's not going to be 11 pi over 2, but give it another full rotation, let's say, what, another 4 pi over 2, so it'll be like 15 pi over 2. You end up at the same place. Sine and cosine are not going to change. And again, that's the reason why they have that diagram, that big circle with all those angles, because all these multiples of 2 pi added or subtracted don't change your y and x values. And that's pretty interesting, I think. So I guess I'll do one more problem here for you with angles, like in exercise 32, for example, 45 and 30 degrees. And maybe that'd be good enough because I already told you that's a holiday. So you probably already think about plans for the long weekend. So why should I be in between you and those important plans, right? Somebody can say, Alex, my plan is to catch up with the homework. Well done, it's good, it's impressive, but I guess some other people may already be done with this quizzes, so you can do something else. So yeah, see, that's the key idea, because once you get used to, it's not that much of understanding, it's getting used to the fact that the sine is y coordinate and cosine is x coordinate. And I think that's the most important part in this whole class, because once you start to feel okay with these two definitions, everything will go. That's the usual stumbling block for lots of people, that they just don't know what sine is. So what is sine? I have no idea. It's y coordinate of point on that unit circle. This is it, y coordinate. And the other is x coordinate, that's for cosine. And from those sine and cosine, everything else will come. You might see, oh, what is that? Tan, tangent. It's coming from sines and cosines. That's why I don't even want to look at those today. I don't want to overwhelm you with this. Once you understand what this sine of 30 degrees means, then you'll be just fine. And same with cosine of 45 degrees. So what I do is I look at the unit circle again. That's the only place that I'm looking at. And yes, you could look at the last page of this book where they have ready answers, but my point is not just to memorize these, but to make sure that you see why sine of 30 degrees is going to be 1/2. So you have the angles 30 produced if you slice that 45 into 3 pieces. So that's a little one, right? 30 degrees here. And you care here about y coordinate, because this is my sine. For that angle, I don't care for x. I just need sine, which is y coordinate. And please notice that this is 1/2. Say, Alex, how can I notice? Well, first of all, whenever you have 30 or 60, we already discussed it, square root 3/2 and 1/2. Those are two big friends, right? We just saw this in the exercise 13. And so whenever you have 30 degrees or 60 degrees, so now you need to decide which one is closer to 1/2, that coordinate or this coordinate. Well, this is definitely not 1/2. 1/2 is right in the middle and between 0 and 1. And that's why your y coordinate, which we call sine of this angle 30 degrees, is exactly 1/2, because the other one will be radical 3/2, right? That always comes with 1/2. If we have unit circle. So that one I don't need, that's a cosine, but I just found that the first piece is 1/2. And that feels good. So now I go for the 45 degrees, and 45 degrees we also just considered. It was square root 2/2, remember? I already forgot. You don't have to remember these. Last page will remind you on that. So I will get my favorite circle here on the left side, and just to recall that if you had 45 degrees angle, so I break this into 2 equal pieces, so it'd be 45 here, then both and x and y coordinates of this point on the unit circle are going to be the same. They both are square root 2/2. So x coordinate is called cosine of this, 45 degrees. And y coordinate, which is also square root 2 over 2, as usual, is called sine. So square root 2 over 2 always counts as multiples of 45. People say odd multiples. Well, so this is radical 2 over 2. And I have to just subtract these two numbers. So my denominator is the same and numerator is going to be 1 minus square root. And that's why they say do not use a calculator, because you could actually put the numbers in a calculator, but it's not going to give you this square root 2. It's going to give you some kind of a decimal, and it be approximation, because if you are working with a square root 2, this is so-called irrational numbers. It's like a 1.4142, something like that. So it's really infinitely long decimal, and that's why if you use a calculator, it'll be cut off, because these are so-called irrational numbers that continue without end. So just like that. Looks like there were some questions. So looks like the question is, yeah, homework is due on October 10th. Yes, because lots of students sent me their homework already, and I'm glad that you are doing it, but I need to see it all together, not just piece by piece, because I may mess up collecting all that and just see which sections you didn't do, which ones you did. It's a big mess. And that's why, since I have so many classes, it just makes it be doing nothing but keep on recording various emails with various homework. That's why, please don't send it to me now. Email it to me when it's due, and that'd be middle of semester. I believe it is October 10, we say. So somewhere in that neighborhood, I will be talking a lot about this date when we get closer to it. For now, just do problems from sections that done in class, and so far we started section 2 of chapter 6. I don't plan to cover it today because there's more in it. There are other functions like tangents, other trigonometric functions, and that's why we will continue with this next week on Tuesday, because I think it's important that I slow down in the beginning and we really grasp the idea, and then we'll feel better when we go to the next sections and chapters, because I think that's important to understand what we're talking about first. So yes, you're very welcome. So maybe I'll stop at this stage and let you, well, get together your things and prepare for this Labor Day holiday. If you didn't know it existed, well, now we all know. Actually, students yesterday told me that, because I also forgot it. Somehow this semester started in kind of hectic way, so I just forgot. But anyways, I think it's a good news to have a long weekend. But again, since for our class you don't get to fully experience it because we don't have class on Monday anyways, well, then I let you go today without a quiz. So have a great time, and we'll continue with this section on Tuesday next week. So no quiz, just have a good weekend. Okay. So I'm gonna stop recording this.
Bye, Professor. Have a good day.
Bye-bye.
Bye.
Bye, Professor. Thank you, Professor.
Bye-bye. Thank you.
Thank you.